Alrighty, I see I have a figure here, and I'm given a couple things to start off with for my two-column proof. So the very first thing that I'm going to write is that J is the midpoint of GI and FH. I am given that statement. And so it also looks like I'm given, based on the figure, and although this isn't written down, I'm also given that GH is congruent, with FI. That looks like it's also given to me. I'm trying to show that Fij is congruent to Hgj. And so I'm basically going to have to use this idea here that J is the midpoint of both GI and FH in order to show my congruence there. So if J is my midpoint specifically of GI, I can actually now say that GJ is going to be congruent to IJ. And that is because of the definition of a midpoint. Remember, a midpoint splits a line segment into two equal parts. And so I'm also going to use that idea that because J is also the midpoint of FH, that I can now say that FJ is going to be congruent to HJ. So remember again, it's super important that I use my corresponding angles properly, and so that's why I have FJ being congruent to HJ. Again, this is because of the definition of a midpoint. And now, based on this, it looks like I actually have three sides that have been shown to be congruent. And I know because of side, 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 when I have all three sides of two triangles that correspond to each other and are congruent, that I can say that triangle now Fij is going to be congruent to triangle HGJ.